Okay. And so we're still doing the same thing with both. We're getting 2 points just in different ways. So we've got 2 different forms of a line. We've got standard form and we've got slope-intercept form. Slope-intercept form is really nice for graphing because then it gives you a point to start out with, the y-intercept, and then a slope that gives you a map to get from one point to the next. The problem is the only way you can write a line in slope-intercept form is if you have the slope and the y-intercept. They almost never give you the slope and the y-intercept. So we need another way to write an equation of a line that will always work. And that's what's going to come next, which is what's called point slope form. Point slope form is what we're going to use 99% of the time when we want to write an equation. Because we don't have to have the y-intercept. We need something even more general, which is great. We need just a point and a slope. It tells you exactly what you need, and it's titled point slope form. So the slope, we already know what that is in the equation. That's the m. And the point that we actually are going to plug in is going to be an x and a y value. So that'll be an x1 and a y1. So this formula is, if you can see it, y minus y1 equals m times x minus x1. And again, where m is your slope and your point is the x1 and the y1. The most important thing that you not forget are these parentheses around the x's on the right-hand side. Why are they so important? Because they're going to tell you to distribute whatever slopes out in front to everything that's on the inside. So again, as a reminder, what we're going to be using this for, this point slope form, is when we're told to write an equation of a line. The problem is, what you can see is this equation is kind of messy, is you never actually leave it in this form. So after you write the equation, then they usually ask you to put it in either standard form or slope-intercept form after you're done. So they usually want you to actually put it in a different form after. So, but this is going to be our starting point always. So let's see. So what we'll do is we're going to write an equation of a line. That's how we know we're going to start out with this point slope form. Is they say we want to write the equation of a line. So whenever you see that, your default should be at least to start with y minus y1 equals n times x minus x1. Well, we just said that our slope in this problem is, what if we go back and read it? It is a -2. So remember, m is our -2. And let's see what else. We know that in our formula, the parentheses are going to stay there, the y is going to stay there, and the x is going to stay here. The only other thing that we can fill in is the point. The point is, let's see, 3, 4. That's going to be our x1 and our y1. So let's go ahead and plug those in. Be careful, the x is 3, so it's going over on the right. The positive 3, so this will stay as the minus that it was. And this was the minus over here. And we're plugging in what for the y1? We're plugging in a 4. Okay. The problem is that gets us started. It looks horribly messy, and that's not what they wanted. They wanted our answer in slope-intercept form. So what that means is you can't stop there. You have to do the math. The math. What math? Well, what is slope-intercept form? It's y equals mx plus b. So that means I need to get rid of the parentheses and I need to solve this thing for y. Well, first of all, how do I get rid of the parentheses? Well, I need to distribute. So I'll get y minus 4 equals, well, distributing that, negative 2 will get me negative 2x plus 6. Now, that's half of the problem. I still need to get y by itself. So how do I get y by itself? I'm going to add 4 to both sides. And that will get me y equals negative 2x. And then 6 plus 4 on this side will get me a plus 10. So there's my equation in the form that they wanted, which was slope-intercept form, the y equals mx plus b. Why is this helpful? This final answer here is because if we wanted to, we could graph it. With the y-intercept of 10, it means we'd be starting at 10 on the y-axis, and then we'd use our slope of negative 2 as a rise over run to get a second point, and we could draw our line. But that's it. So we couldn't have done this really with just starting out with y equals mx plus b. Why? Because they didn't give us the b. They didn't give us the y-intercept. They gave us a point, 3, 4. But that isn't the y-intercept. That's just a random point.